Hi, this is Roberto and I'm going to teach you physics. Close the door. Yesterday we were studying the exponential function, and today is a nice day because it's my son's birthday, and I'm right now, focus? Yes, I'm right now waiting for my girlfriend. Well, my son does not know she's my girlfriend. Well, he's not stupid, so I might have guessed that she is my girlfriend, but anyway, I didn't tell him. And he's a teenager and he doesn't want anything. So by surprise, I have his presents. And my girlfriend is bringing a cake with candles and stuff. So I think he's going to like it, even though he didn't want anything. Yeah. So she's about to arrive, and I don't have much space. So yeah, let's continue. I didn't know. I don't know if I said Roberto. I'm going to do his way anyway. So, the exponential function is very important in maths, but in physics we just carried away by mathematicians because one common example is the exponential decrease. Okay, so for instance you can do it with hot water. For instance, you get a cup filled with boiling water. I measure it, and then when you put a thermometer in a cup and then you pour boiling water, because of the heating of the mug itself, okay, the temperature drops until 85 degrees, something, 15 degrees, yeah. But anyway, let's suppose that water is at, this is temperature. I'm giving you an example, so for the exponential function, and this is temperature and this is time. This is temperature in degrees Fahrenheit, in Fahrenheit. Celsius, Fahrenheit I'm not familiar. So, but the idea is the same. Even the values change. So, if it's boiling, the temperature is 100 degrees, and if it's ice, forming ice, is 0. So, what happens if time passes? Okay, let's say like 1, 2, 3, 4, 5. Let's start. It's an alarm. Okay. Yeah, I already did it. I reminded. Yeah, don't worry. So, what happened in 2, 5, or let's say this is I don't know, like 2, 6, 8, 10, 12, 14 minutes. You know what happens? Temperature drops in a fashion like this, and this between these values, this is the initial temperature, or T0, the initial one, and T, I call it T room, the environment, the room temperature. Temperature drops in a fashion like this. If you measure the points, it might be exactly, but very close, really close. Okay. So there's a tool called least square minimization. With it, we can measure we can get the temperature drop, and the function is the exponential. Yeah, but I made some. I'm sorry to say that this exponential decrease can be also described with a power 10 decrease. Okay, so it will be like something like temperature is a factor a plus b 10 power minus a factor c and temperature. Okay, with a factor 10 also works, but anyway, we're going to give that to the mathematician. That exponential is easier for equations. Okay, for equations. Why? Because this, there's advanced ideas, but this equation comes from a differential function. Okay, not in this form, but in the exponential way. So anyway, the purpose of this of this lecture is to help you understand that exponential appears in nature. Yeah, exponential power 10, but anyway, exponential appears in nature. And what we are really interested is in what? In solving the exponential equations, because they are helpful. Yeah, I'll tell you one day. I'll tell you a story, and I don't have time now, and I don't have the experiment itself for an exponential equation. So let's just consider that we did this experiment. We did it later, okay? I'll try to do it tomorrow. And we get an equation like this, y equal y 0 exponential of minus alpha x, okay? An exponential like this, with x and y, so as impersonal as I can think, okay? Because in physics, x and y are usually different quantities, physical quantities, not just x and y, okay? But yeah, I'll show you an example tomorrow. Yeah. So the idea is that from that initial y0, y decreases, and this alpha with x, okay? X can be anything, for instance, time. Alpha gets the rhythm, okay? The rhythm is a coefficient of, we call it, I don't know, cooling coefficient, or I don't know. Yeah, it's a coefficient of the phenomenon that we're studying. So it's related to the rhythm, of variation, You know, in variation in physics, every quantity must have a. I remember my boss telling me that when I started my PhD. That in physics, every quantity must have a physical meaning. They're not. Yeah. So this y0 will be the initial value. Okay, the initial value, meaning when x equals 0, how much is y? Y is y0. Yeah, and it's related. So x and y are the quantities. Usually could be a number of things, for instance, temperature or whatever, and x could be the time. But anyway. So how can we solve this equation for alpha? Because it's a common concern. How to get alpha? How to get alpha? About the battery, I don't know. I think it says they have 27 minutes left. Yeah, okay. I think I'll have enough. So how to get alpha? That's our question. So the first thing is that, it's like every time I see a question like this, reminds me that from time to time in Spain, people find bombs from the Civil War. The Spanish Civil War, was between 1936 between 1931, and they still finding bombs that didn't explode, in abandoned